Okay, so let's do another problem. So there are two blocks that can move, that can ride up and down. So there's block B here, block B, and which is connected to block A, and so these are connected like that. Okay. And what else? We know that what is given is the block A has a velocity of 4 meters per second. Everything that is given, I'm going to write that in black. And we know that this AB is 800 millimeters. Okay. There's a point C such that BC is equal to 200 millimeters. Of course, we know VA is 4 meters per second moving towards the left. And what else is given? And we know this angle theta, that is 28 degrees. I think that's all is given. And what do we need to find? So here I'm going to write theta is 28 degrees. So what we're required to find are these: omega AB, VB, VC. Okay, so said this is 800 millimeters, and from B to C, that's 200 millimeters. So that's all given. Right, so how do we go about finding these things? First of all, we need to find the instantaneous center of rotation. How do we do that? So if A is going this way, then B has to ride up, right? Because these two blocks are connected by this rigid rod, so B has to ride up. So this instantaneous center, which is somewhere here, let's find that. So if we draw a line going up, and then so that's our instantaneous center O, and then omega is this way. Why? Because if block B is going up and A is going left, then this bar is turning clockwise. So that's our omega. All right, so let's do some simple geometry and find the distances. Okay, so we need OA first. OA is given by 800 sine 28 degrees. Right? So that's equal to 375.8 millimeters. Okay. OB is 800 cosine 28 degrees, so that comes to 706.4 millimeters. Okay, now so let's find distance of C, right? Because we also need to find VC, so we also need distance of C from O. Okay, so to find that, let's look at this triangle BCO. Okay, we know BO or OB, which is 706.4. We know BC 200 millimeters, that's a given, and we need to find R, so we need to find this OC. Okay, and we know this angle is 28 degrees. How do we know that? How do we know that? We know that because look at this, so this is parallel to this, that's the transversal, so that angle should be equal to that angle. Okay, so this angle also becomes 28 degrees. So we're drawing triangle BCO. Okay, so now we know that we could go ahead and either use the we could go ahead and use the cosine rule, right? We could go ahead and use the cosine rule to get OC. So okay, so OC square is equal to this 706.4 square plus 200 square minus 2 times 706.4 times 200 times cosine the angle between them, which is 28 degrees. So when you do that, you get 538 millimeters. You get OC as 538 millimeters. Please check my arithmetic here. Okay, so we have all the distances, and what we need to do is find omega first. Once we find omega, that omega is going to be the same for points A, B, and C. And we know omega A, that means we know omega A, omega B, omega C. If we know the distances from the center to A, center to B, center to C, which we already found, we can find VA, VB, VC. Okay, so how do we find omega? We can find it from V equals R omega. This is for point A. So we know VA, right? So this is R is actually OA. Okay, we know VA is already given, which is 4. R is what? OA. So OA is 375.8. 375.8. Right, so we'll divide that by 1,000 to convert meters to millimeters to meters, right? Because 4 is in meters per second, so this is 4 is meters per second, so everything has to be meters. And omega is what we need to find, so we get omega is equal to 10.6 radians per second. So we take this omega, V equals VC equals OC times omega. Okay, so OC is what? 0.538. 538 is what we got, so I'm converting that to meters. Okay, times omega is 10.6, so we get 5.7 meters per second. That's VC. VB is OB times omega. OB is 0.706, right? 706.4 millimeters. So I'm just rounding it to meters. 706.706 meters times again 10.6. You get 7.5 meters per second.